Participants, welcome to MOOCs on Water Resources and Watershed Management by Wrwm. This is Dr. Harish Gupta, UGC Assistant Professor, Department of Applied Geochemistry, Osmania University. This second module is on surface hydrology. The social, economic and political well-being of human society and the functions of terrestrial ecosystem depends on the availability of fresh water resources. However, exponential growth in human population combined with the improved standards of living are posing enormous strain on the availability of our natural resources. So, meeting the demand of fresh water for societal use become one of the most pressing global issues. Due to global warming, annual precipitation patterns are bound to change at local, regional and global scale. Though there is no much change in the total annual rainfall, however, change in rainfall intensity and periodicity is well recorded. It is bound to make the availability of fresh water resources more uncertain. For a better planning and management of water supply, a good understanding of availability and distribution of surface water resources is required. In this context, this second module is designed to introduce the subject of surface hydrology. In the first lecture of this module, I shall focus on the hydrological cycle, various concepts necessary to understand the hydrological cycle and the distribution of fresh water resources on the Earth's surface. Earth is a complex system with number of key components: the atmosphere, the hydrosphere, the lithosphere and biosphere. I am sure that you are well aware about all of these components. These all components play important role in running the Earth system. All water on the Earth is distributed among these Earth system components. The hydrosphere represents the liquid water component of the Earth. The total mass of Earth's hydrosphere is about 1.9 billion cubic kilometers, which is about 0.023% of Earth's total mass. However, it covers approximately 75% of the Earth's surface. It includes the oceans, lakes, seas, ponds, reservoirs, rivers and streams. The water cycle, also known as the hydrological cycle or the hydrologic cycle, describes the continuous movement of water on, above and below the surface of the Earth. The mass of the water on the Earth remains fairly constant over the time, but the distribution of water into ice, fresh water and saline water and atmospheric water is variable depending on a wide range of climatic factors. The water moves from one reservoir to another, such as from rivers to ocean or from ocean to the atmosphere by the physical processes of evaporation, condensation, precipitation, infiltration, surface runoff and subsurface flows. In doing so, the water goes through different forms. This sketch provides a broader overview of the global hydrological cycle, where the circle represents Earth system components, boxes are pools respective to that particular component, arrows are pathways and terms in italics are the processes. The water cycle involves the exchange of energy which leads to temperature change. When water evaporates, it takes up energy from its surrounding and cools the environment. When it condenses, it releases the energy and warms the environment. These heat exchange influence the climate. In the previous picture, I have mentioned several processes which are integral part of the hydrological cycle. Let's learn more about them. Precipitation, it includes all liquid and solid water particles that fall from clouds and reach the ground. These particles include drizzle, rain, snow, snow pellets, ice crystals and hail. Rainfall is the predominant form of precipitation. The second process is evaporation. It is an important process in global water cycle. Solar radiation hits the surface of water in the oceans or on the land, and it results in water to change state from liquid to gas. This is how water vapor enters into the atmosphere. Now, the moisture in the atmosphere is linked to the cloud formation and rainfall. Transpiration, another form of evaporation where water evaporates from the leaves of plant. Whereas evapotranspiration is sum of evaporation and transpiration. There is another term we frequently see in the literature, which is known as potential evapotranspiration. This potential evapotranspiration, or PE, is a measure of the ability of atmosphere to remove water from the surface through the process of evaporation and transpiration, assuming no control on the water supply. The amount of energy received from the sun determines the regional and global variation in potential evapotranspiration rates across the world. The potential evapotranspiration rates are highest in the tropical regions. Now let's talk about another important process, which is condensation. Condensation is the process by which water vapor in the air is changed into liquid water. Condensation is crucial to water cycle because it is responsible for formation of clouds. These clouds may produce precipitation, which is the primary route for water to return to the Earth's surface within water cycle. Condensation is opposite to the process of evaporation. Infiltration is the process by which water on the ground surface absorbed by the soil. Whereas if water seeps through tiny spaces and cracks between rocks and soil particles, it is termed as percolation. Both percolation and infiltrations are important part for recharging the aquifer below the ground. The quantity of precipitation which is not absorbed by soil and does not evaporate finally reaches to the streams. This overflowing water is termed as surface runoff. Let's see why these processes are crucial part of water cycle in transforming the water in one form to another form. Usable fresh water comes from rainfall over the land generated through the hydrological cycle. Water is recycled continuously as a result of evaporation driven by solar energy. Evaporation happens from all wet surfaces including oceans, rivers, lakes, soils, and the leaves of plants. Water vapor is further released as transpiration from vegetation and from humans and other animals. Groundwater flow and water drawdown from aquifer also add to the water cycle. Water vapor and cloud cover, which are the primary observer of infrared radiation in the Earth's atmosphere. If you look this sketch, you will observe that your left side water evaporation from the ocean is represented, and at your right side you have water evaporation from the land surface. You will observe that more water evaporates from the ocean than falls on them as precipitation. If you compare, land surface contribute only 12% of total evaporated water. However, it receives about 20% of all precipitation over the earth. Thus, there is a continuous transfer of fresh water from ocean to land through rainfall. This excess water flows back to the ocean through rivers and submarine groundwater discharge. Let's see why these processes are crucial part of water cycle in transforming the water in one form to another form. In continuation of previous slide, this picture quantifies the amount of water which is recycled among the various pools annually. the blue arrows represent the amount of water which turns to water vapor, whereas the gray arrows illustrate the amount of precipitation. The width of the blue and gray arrows is proportional to the volume of transported water. On the land, evaporation and evapotranspiration is the major processes resulting in water losses to atmosphere, followed by the evaporation from surface water bodies. However, rate at which the water from one pool to another pool recycled differs. For example, the atmosphere can accommodate little more than 2% of water at any given point of time. That means the total amount of water evaporated to form vapor requires to pass through the hydrological cycle 45 times in a year. The length of time that particular water molecules stay as a part of particular pool is known as residence time. This highlights another dimension of Earth's hydrological cycle. The residence time of water among the pools is quite variable. It means that water does stay in certain pools longer than others. The residence time of biospheric water is about 1 week. The average residence time of water in rivers is about 2 weeks. However, it is about 10 years for water in the lakes and reservoirs. A water molecule may stay up to 400 years in an ocean, or 1000 years to 10,000 years if it becomes the part of ice cap or glacier. Interestingly, the average residence time of water in the groundwater pool can be anything between 2 weeks to 10,000 years, which is specific to that particular area. Another dimension of the hydrological cycle is uneven distribution of water across the pools. Most of the water on the earth is saline, and oceans are the largest pool of this saline water, and they contain about 97.5% of total water on the earth. Remaining 2.5% water is known as fresh water. Almost 69% of this fresh water is tied up in glaciers and in ice caps. About 30% of fresh water forms the groundwater. Merely 0.27% of water is available in form of surface water. If we compare the abundance of groundwater and surface water, we will realize that almost 96% of Earth's fresh water is in form of groundwater, whereas only 4% of this water is available in streams, lakes and rivers and in wetlands. A small proportion of fresh water is retained in atmosphere or as a soil moisture or in biosphere.